Okay. Let's continue with particle nature of light. We had to complete one more numerical in particle nature. Hello. Chalo. So let's understand this, people. Question says a photon of wavelength 300 nanometers is absorbed by a gas and then emitted as 2 photons. One photon is of wavelength 760 nanometers. Then calculate the wavelength of the second photon. Okay? So I have, let's say, a gas. Assume this to be that gas. And what's happening with the gas, people? I have a photon. What is the wavelength of this photon given? So let's say lambda is 300 nanometers. And this photon is absorbed by the gas. What happens after that? Then it is emitted as 2 photons. Photon number 1 and photon number 2. One photon is of wavelength, so lambda 1 is 760 nanometers, somewhere around the wavelength of red light. What do we have to calculate? The wavelength for the second photon. Did you get the question? Any doubts? Now what we use here, people, is the law of conservation of energy. Can anyone tell me what is the law of conservation of energy? Energy can neither be created nor can be, but can be converted from one form to the other. So can I say that the energy of this photon, which was absorbed by the gas, let's say the energy here is E1, E. Let's take the energy here is E1 and the energy here as E2. So if I apply law of conservation, what can I say? E is equal to E1 plus E2. Anyone who did not get that? What is the formula for energy of a photon? So E is hc over lambda. This E1 का formula क्या हो जाएगा, people? hc over lambda 1. Because h is Planck's constant, c is what? That's also a constant. Plus, how will you write E2, people? कुछ common दिख रहा है? hc. We can do that. So now what are we left with? 1 over lambda is plus 1 over lambda 2. Bolo re. Let's substitute the values. 1 over lambda is how much, people? 300 nanometers. See, usually some numericals we had converted. यहाँ पे even if you don't do it, it's okay because all the parameters are in the same unit. Final answer भी जो मिलेगा, they will get that in nanometers. That is equal to 1 upon, how much is lambda 1? 760 plus 1 over lambda 2. Lambda 2 is what we are looking for. अब बस match करना है. 1 over 300 minus 1 over 760. So, can I say 1 over lambda 2 will be 760 minus 300 over 760 times 300. How much is 760 minus 300? So it's like 460 over 760 into 300, and therefore lambda 2 will be 760 into 300 over 460. Calculate and give me the final answer. Thank you. Okay, baby. Now, the next topic that we start is atomic. Till 10th standard, what's the basic atomic model that we have studied? Center of the atom क्या है? Nucleus. Nucleus के अंदर. And what is revolving around the nucleus in circular orbits? वो भी आपने कुछ पढ़ा होगा. In the first shell, how many electrons are there? Second shell, 8, then 18, then 18, then 32. These are called as magic numbers. We'll study more about those in periodic table. Okay? But that's not the first model which actually came out. Before that, there were certain atomic models given. So आज हमें वो उसमें से दो basic atomic model that we have to learn. Now Thomson discovered electron. Now, once electron was discovered, he gave his own model. Remember, he discovered the electron. बाकी subatomic particles का discovery was not done. So, what Thomson thought is there is a negatively charged particle, and if an atom is neutral, to balance the negative charge, there has to be something positive. So, the first atomic model which was given is called as Thomson's model. Or Thomson's atomic model. Now let's understand Thomson's atomic model. Thomson's atomic model states that he assumed the atom to be spherical in shape. Since we have a two-dimensional board, circle दिखेगा. But an atom is what shape? Spherical. Okay? Remember, no other subatomic particles are discovered, so सिर्फ electrons है. So he said since electrons are there, there has to be positive charge. So what he said, inside the sphere, positive charge is uniformly distributed. Something like this. Students uniformly sitting in the classroom. So positive charge inside this sphere is uniformly distributed. थोड़ा सिंप्लीफाई करने के लिए इमेजिन दैट यू हैव अ पिज्जा बेस. पिज्जा बेस इज अ टू डिमेंशनल बेस, सर्कल है. तो इमेजिन कर लो ये पिज्जा बेस है. आपने पिज्जा, लेट्स से यू आर मेकिंग अ पिज्जा एट होम. पिज्जा बेस लिया. व्हाट डू यू डू विद द बेस फर्स्ट? उसके ऊपर क्या लगाते हैं हम? दैट बेस सॉस. सो इमेजिन द पॉजिटिव चार्ज टू बी लाइक दैट बेस सॉस. ऐसे कि आधे पे ही सॉस लगाओगे क्या? You will spread it uniformly throughout the base. So I say uniformly throughout the base, the sauce is, positive charge was distributed. समझा इधर तक? Next is, after the base, what do you add? Cheese. Actual pizza, cheese के ऊपर क्या डालोगे फिर? Toppings, depending upon your dietary preference. Those toppings are electrons. Did you people get that? Those toppings were electrons, and the positive charge of the atom is balanced by negative charge of the electron. This was the first basic model. This is also called as the Plum pudding model. Or watermelon model. like watermelon seed model, or raisin pudding model. So like imagine a spherical watermelon, उसके अंदर seeds हैं, those seeds are your electrons, and everything present inside is like the positively charged, positive charge uniformly distributed. Did you get the first model? Remember, there was no nucleus discovered, there was no protons or any other subatomic particles discovered, so this was the first model. However, eventually when there were some more experiments done, the model did not really stand. For example, the model couldn't really prove something called as atomic spectrum, or couldn't explain spectrum. Spectrum is something that we'll study later half. But what is a spectrum? For example, what's the spectrum of white light? Vibgyor. Vibgyor is the spectrum of white light. If you pass white light through a prism, it is distributed into 7 different wavelengths. It's called the spectrum. Just like white light has that spectrum, every particular element on the periodic table has a spectrum. So atomic model, Thomson's model couldn't really explain what exactly that spectrum is. Some more scientific experiments, one of the major drawbacks is there's no mathematical proof for the experiment. And that is the reason once the subatomic particles were discovered or atomic models, eventually the model was discarded. Did you will get that? Samjha? Quickly copy the diagram, then we write the theory. Please write down. Thomson proposed that an atom possesses a spherical shape. In which positive charge is distributed uniformly and the electrons are present in such a way that the overall neutrality of the atom is maintained. However, the model couldn't explain spectrum and was not consistent with results of different experiments. Okay, so that was the first atomic model. Now we move on to the second atomic model, which is Rutherford's model. and this is Rutherford's gold foil experiment, or this is also called as Rutherford's alpha particle scattering experiment. I'm so sorry. I think you people have done this in class 9, yeah, class 10, class 7. Okay. I don't know which class, but probably it was done. So let's quickly revise this and थोड़ा सा additional करेंगे इसमें. राहुल टेंशन में आ गया. राहुल, what happened today? कुछ टेंशन. Alpha particle experiment. चलो. Now, so what we first need here is we need an alpha particle emitter. So हमने एक radioactive isotope लिया. ठीक है. Or we have an alpha particle. So this emits what, people? It emits. I forgot what were alpha particles. They were doubly ionized helium nuclei. Yeah, they were. Helium, say when you remove the 2 electrons, what do we get? Alpha particle. I repeat, helium has 2 electrons, 2 protons, 2 neutrons. Remove both the electrons, आपको मिल गया alpha particle. With me till here? Now see, this would emit alpha particle in all directions. Yes or no? But we want थोड़ा सा concentrated source. I mean, in one particular direction में we want the particles. So हम क्या करते हैं यहाँ पे? We place this inside a metal block. ठीक है? I repeat, this was placed inside a metal block. Let me tell you, but it would still emit alpha particles in all directions, something like this, people. Yes or no? But we still want a focused ray. So हम क्या करते हैं? We place a metal sheet. ठीक है? With a tiny gap. It should be a bit more tiny, but I think we will get it. Did you get that? When I say I want a focused alpha particle ray. Next हम क्या करते हैं? We have this incidented on a very thin gold foil. I repeat, it should be very, very thin gold foil. You know how thin? काजू कतली का है, उसके ऊपर you have a silver foil. वो foil का thickness, वो beaten up silver से वो foil का जो thickness मिलता है, we want exactly but gold foil. थोड़ा सा heavy nucleus चाहिए था. So we took gold foil. इधर तक समझा? Any questions still here in the setup? And what he did next is, no, they can't. When we look at penetrative power, who had the maximum penetrative power? ठीक है? So what we did is we placed screens all around. Any questions here? What screens were these? Fluorescent screen, zinc sulfide. So all these are fluorescent screens. Whenever a charged particle will collide with these screens, you'll see a tiny glow. With me till here? Probably when Rutherford was doing this in a dark room, and probably he took 4 or 5 of his students और screen लेके पूरे टाइम उनको खड़ा रखा था उसने when he was doing the experiments. Probably all his PhD candidates. अब क्या हुआ? The experiment starts. So these are the alpha particles. What was observed is majority of the alpha particles went straight through the foil. I repeat, what happened, people? Majority of the alpha particles went straight through. Very few alpha particles got deflected through small angles. Getting that? And extremely few, 1 in approximately 20,000 particle. I repeat, 1 in 20,000 particle got deflected backward. Making large angles. Did you get that? Any questions there? Yes or no? So, what were the different observations and conclusions? We need a very thin layer of gold atoms. So, this is, let's say, a gold atom. Center of the atom, what do we have, people? We have the nucleus. Okay. What you observed is majority of the alpha particles, or you can say like 99% of the alpha particles went straight through. Conclusion, majority of the atom is empty or void. Now when I say majority of the atom is empty, it's that amount of the atom is empty. How did we come to that conclusion? The amount is empty because majority of the alpha particles went straight through. No deflections at all. With me? Very few alpha particles got deflected via a small angle. What happened is when these alpha particles, what's the charge on an alpha particle, people? Positive charge. What's the charge on the nucleus? Positive charge. And hence when an alpha particle came close to the nucleus, which means that what Thomson had said is that mass of the atom is divided uniformly throughout the atom. But that is not true. Mass of the atom is concentrated at its center. I repeat, according to Thomson, it was uniformly distributed. The mass of an atom was uniformly distributed throughout its sphere. But where Rutherford's experiments proved that no, mass is concentrated in a very, very tiny center. The center is so tiny is that if you look at the radius of an atom, the radius of atom is around 10 to power minus 10 meters. But when you compare that with the radius of nucleus, it is 10 to power minus 15 meters. If you want a context to understand the difference in size and the amount of void space, let's actually enlarge the atomic world. Imagine Guru, you are watching a football, or a cricket match. I want a sphere. Like a cricket stadium is circular. Imagine the center of the stadium, you place a cricket ball. That cricket ball is your nucleus. That entire stadium is the atom. बाकी का जो space है, that entire space is empty or void. And if you want to imagine an electron somewhere in that space, keep a hair strand somewhere in the stadium. That is the proportion. Baki everything present inside the atom is empty. Did you get that? And remember that one particle in 20,000. What happened to that one particle? That one alpha particle had a head-on collision with the nucleus, and it was a bulky nucleus. इसलिए gold लिया है. Atomic mass number 197. Gold. Atomic number 79. And it, what happened? Came back. This was one particle in 1 in 20,000. Any questions here? Yes or no? इसके बाद एक छोटा सा derivation भी करना है. If you really want to understand कि ना how was the radius of the atom or radius of the nucleus discovered. समझा? Copy the diagram, then we'll write the theory. Please write down observations and conclusions. Most of the alpha particles passed straight through the foil. Undeflected. Passed straight through the foil undeflected. Full stop. Hence, most of the atom is void space. Most of the atom is void space. Second point. Few alpha particles were deflected by small angles. Few alpha particles were deflected by small angles. And 1 in 20,000. And 1 in 20,000 deflected back. You can also write bounced back. 1 in 20,000 bounced back. This shows that positive charge is not uniformly distributed through the atom. Positive charge is not uniformly distributed throughout the atom. Positive charge is not uniformly distributed throughout the atom, as predicted by Thomson. As predicted by Thomson. But is concentrated in a very tiny space. Rutherford named it as nucleus. Rutherford named it as nucleus. Rutherford named it as nucleus. Next point. The radius of the atom is around 10 raised to minus 10 meters, whereas the radius of the nucleus, the radius of the atom is around 10 raised to minus 10 meters, whereas the radius of the nucleus is around 10 raised to minus 15 meters. Rutherford calculated this. Using the distance of closest approach. Underline the last 4 words. Distance of closest approach. Distance of closest approach. With me till here? Chalo. Now, before we understand what is the meaning of distance of closest approach, we need to go थोड़ा सा into physics. एकदम deep में नहीं जाएंगे, थोड़ा सा ऊपर ऊपर touch करेंगे. We study something called as Coulomb's law. Now, let's say we have 2 charged particles, Q1 and Q2. These charged particles can be positive, or both can be, or one positive and the other is negative. So Coulomb's law can be applicable to 2 particles which are similar or dissimilar in charge. This is Coulomb's law or force of attraction. Coulomb's force of attraction if the particles are dissimilar, or force of repulsion. I repeat, both the particles, if they carry the same charge, they will repel each other. If they carry opposite charges, they will attract each other. The law states that the force of attraction or the force of repulsion, F, is directly proportional to the product of the 2 charge. 10th standard, 9th standard में law of gravitation था. What is the law of gravitation between 2 bodies, M1 and M2? Anyone remembers?
G into M1 M2 by
G M1 M2 by R square. The force of attraction between two large bodies is M1 into M2, directly proportional to the product of the masses of the bodies, inversely proportional to the square of the. कुछ पढ़ा था ऐसे 10th standard 9th standard somewhere. It's exactly the same thing we are writing. The force of attraction between the two charged particles will be product of the charge and inversely proportional to the square of the distance between the two charge. With me till here? दोनों को combine करके हम क्या लिख सकते हैं people? F is Q1 Q2 upon R square. F is proportional to Q1 Q2 over R square. To remove proportionality, we introduce a constant. What was the constant there? Capital G लिखा था, यहाँ पे हम लिखते हैं K. फिजिक्स में थोड़ा किया था कि ये आई थिंक डायमेंशंस निकालने बोला रहेगा, इसका कुछ नहीं किया तो भी चलो ठीक है. K Q1 Q2 upon R square. What is K people here? K is our constant. This constant K is given by 1 upon 4 pi epsilon or 1 upon 4 pi epsilon naught. I'll explain what that means. Epsilon is called as permittivity in free space. थोड़ा सुनने में लगता है what is permittivity in free space. What that means is, let's say you have a medium in an electric field. It is its electric charge holding capacity. How much electric charge can that medium hold? Simple terms में K का value people is around 9 into 10 to power 9, and if we try to find the unit, this is force. Force का unit क्या रहता है people? Newton. Radius इसको ले लेंगे हम meters में. Charge को हम ले लेंगे in coulombs. So I'm looking for the unit of K. So this R square will go to the left. Q1 Q2 will come to the denominator. So numerator में I have force, which is Newton meter square over coulombs, and Q1 into Q2 coulomb square. Coulomb बोलेंगे तो भी चलेगा, Newton meter square per coulomb. Did you people get that? बोलो रे. चलो. Now this is the force of attraction between two charged particles. Similarly, let's say I have two charged particles, Q1 and Q2. Then the potential energy is given by K Q1 Q2 upon R. What is the formula for potential energy? K Q1 Q2 by R. We're not doing the derivation, वो आप physics में कर ही लोगे, but we need to know this when we apply distance of closest approach. Any questions still here? Now potential energy can be positive or it can be negative depending upon the particles into consideration. For example, I have these two particles. Let's say particle 1 is positive, particle 2 is also positive. What is the formula for potential energy? Q1 excuse me, K Q1 Q2 over R is K. Q1 positive, Q2 positive, obviously radius and K to positive hai. So the term on the right will be, so in case when both the particles are positive, my potential energy is, similarly when both the particles are negative, तब यहाँ पे क्या हो जाएगा, potential energy will be K, negative into negative by R, that will again become positive. But when will potential energy be negative? When one of them is positive, the other one is, then potential energy will be, directly लिख दूँ अभी? Anyone who did not understand this? Yes or no? बोलो रे. पक्का? Second, what is the relation between potential energy and radius? Inverse. So if the radius increases, what happens to potential energy? And if radius decreases, potential energy will not always. Let's understand this. If I have for the first two conditions, that is when both the particles are either positive or both the particles are either negative, I repeat, when both the particles are either positive or both the particles are either negative, so potential energy is, and as radius will increase, ये short form समझेगा, as radius increases, how do you read this? As radius increases, मतलब denominator increases, so potential energy decreases. With me? But if I have the next two conditions, like one of them is positive, the other is negative, this is K positive into negative over R, so potential energy will be negative into K by R. Positive है कि negative है? So here as radius increases, potential energy will also increase. The reason why we are writing positive, positive, negative, negative, आगे समझेगा. Why? Because what is the charge on an alpha particle? Positive. Charge on nucleus. So two positive particles, the final potential energy is going to be positive. But if I compare electron, charge on the electron, negative. Charge on proton or charge on the nucleus, positive. So what is the potential energy between nucleus and electron? Negative. Did you understand the difference between the two? That is why इतने सारे combinations ले रहे हैं. Now what is distance of closest approach? We know that 1 in 20,000 particle came backward or bounced back. ये आपका nucleus है. What is the charge on the nucleus? I repeat, what's the charge on the nucleus, people? Positive. What is the charge on alpha particle? So यहाँ पे एक positively charged alpha particle आ रहा है, which is a doubly ionized helium nuclei. ये particle किसके पास आया? It was traveling towards which particle? Towards whom? Do you think did it actually touch the nucleus? Why? Both are positive. So imagine I have two north poles magnet ka, can I really touch them? Do they really come close and touch each other? There's always a gap. उसी gap को हम बोलते हैं distance of closest approach. How close can you bring that same poles of the magnet? Similarly यहाँ पे how close can the alpha particle come? Because alpha particle आया, this was the maximum, and what will happen from here? It bounced back. Anyone understand this? इसको क्या बोलते हैं हम? Distance of closest approach, and it is this distance that we have to find. And this was the distance which also helped Rutherford find the radius of the atom and the radius of the nucleus. Any questions still here? Chalo. This is a particle which is moving. A particle moving has what energy? Particle in motion has what energy? Kinetic energy. यहाँ पे कौन सा energy उसके पास? Kinetic energy. It's moving. What happens when it comes here? Will it speed up or will it slow down? Slows down. Kinetic energy is getting converted into potential energy. Anyone who did not get that? So the kinetic energy which was present here got converted entirely into potential energy, and then it bounced back. Basically, law of conservation of energy लगा रहे. So kinetic energy is equal to what energy, people? Potential energy. Kinetic energy at this point will be equal to the potential energy at this point. What was the formula for kinetic energy? Half mv squared. I think everyone knows the formula for kinetic energy. M here is the mass of alpha particle. What does m alpha stand for? Mass of alpha particle. What does V alpha stand for? Velocity of alpha particle. I think you people can write that. What was the formula of potential energy? K into Q1 Q2 upon R square. You know what that R is? समझा? What is Q1? Charge on the first particle. Which is the first particle? Which is the first particle? Alpha particle. What is the charge on alpha particle? What is the charge on alpha particle? 2 into charge on proton. Yes or no? To keep this simple, I write this as 2. This I write it as E. What is Q2? What is Q2? न्यूक्लियस किसका न्यूक्लियस न्यूक्लियस ऑफ gold atom. What will be the charge on that nucleus? What is the charge on that nucleus? This page can help you to identify the charge. This page can help you in identifying the charge. Inside the nucleus, how many protons are present?
79.
गोल्ड के न्यूक्लियस के अंदर कितने प्रोटॉन्स है? लाउडर 79. तो इसके अंदर कितने प्रोटॉन्स प्रेजेंट है? 70. What is the charge on each proton? What is the charge on each proton? 1.6 into 10 raised to. अभी मैंने यहाँ पे गोल्ड एटम लिया है. Can I take some other atom? Can I take silver? Can I take any atom in the periodic table theoretically? Yes. How will I find its charge? Z. Z stands for atomic number into E. E is the same charge. Did you people get that? बोलो रे.
Yes.
Substitute that here. So half m alpha b alpha squared is k. What is q1? 2e q2 ze over, pardon me, r square nahi, r. Therefore half m alpha b alpha square is k. 2 z e into e is e squared upon, so I want radius r. r इधर आ गया. पूरा फॉर्मूला क्या हो जाएगा? 2 k, 2 into 2, so 4 k z e squared upon m alpha v alpha. That's the formula for the distance of closest approach. Anyone who did not get that? Any questions still here? Bolo re. Okay. Now, last topic for the day. Excuse me. Limitations of Rutherford's model. Now, Rutherford's model mein there is a small problem, but there was a question raised. See, we know that according to Rutherford, center of the atom, what do we have, people? Nucleus. And what is revolving around the nucleus? In circular orbits. Yes or no? Later it was, there's one more theory, Sommerfield's theory, which is that the orbit were not circular, but they were elliptical. However, see, electron is a charged particle. Nucleus is also a charged particle. When a charged particle will move around another charged particle, it gives out energy. Basically, it will radiate energy. And eventually, what will happen is the energy of the electron should decrease and decrease, and eventually it should collapse or spiral inward into the nucleus. Something like this. Let's say we all go to a cricket stadium. I am the nucleus, I am in the center, and I make you all run in circular orbits. What will happen eventually? Can you run continuously? You will eventually drain out, energy will become zero. Somewhat similar may, why isn't the electron losing energy when it is continuously revolving around the nucleus? Data says that this should happen in less than 10 raised to minus 8 seconds. Why isn't the electron losing energy and collapsing into the nucleus? That was something which couldn't be proved by Rutherford. And why is that not happening? And we all are here, so thank God that is not happening. Second, we all know the distribution of electrons, right? आपने पढ़ा है 10th standard, 2, 8, 18. Now that distribution of electrons around the nucleus was something which was not given by Rutherford. So there are certain limitations even to the Rutherford's model, and that is why next class we will start with something called as Bohr's atomic model, a further improvisation of Rutherford's atomic model. Okay, so please write down limitations of Rutherford's model. Limitations of Rutherford's model. According to Maxwell's electromagnetic theory, according to Maxwell's electromagnetic theory, when a charged particle revolves around another charged particle, it emits energy in the form of radiation. It emits energy in the form of radiation. Energy in the form of radiation. And hence the electron should lose energy, and hence the electron should lose energy and spiral into the nucleus, and spiral into the nucleus. However, Rutherford couldn't explain the stability of the atom. Rutherford couldn't explain the stability of the atom. Next point. The atom doesn't explain the arrangement of electrons around the nucleus. The arrangement of electrons around the nucleus. It also doesn't explain atomic spectrum. It also doesn't explain atomic spectrum. ठीक है. We stop here for the day. Next class we first start with a numerical on distance of closest approach, and then we'll do Bohr's atomic model. Thank you all.